Well, according to me, most students study to score well in exams, but they should also realize that studies, on the other hand, also enhance our general knowledge. Hi, I'm Arjun Bhagat, and today I'll help you in accepting this fact. In Topper's Exam Special, our topic today is P block elements, and I'm sure you'll be able to tell how much you know of this topic and also how much preparation is still required. So let's take a look at our first segment, Trend Spotting.
The unit P block elements carries a total weightage of 8 marks out of 70, which makes it around 11% of the question paper. One can expect short answer type questions worth 1, 2, 3 marks or even a 5 marks problem.
Now you have a fair idea as to what portions of the chapter should be given more attention. But before we begin with the questions, let's review the contents of this chapter through our next segment, Recap.
In this chapter, we learnt about nitrogen and its oxides, the oxyacids of phosphorus and their structures. We also learnt about sulfuric acid, interhalogen compounds, and noble gases.
I hope you're all geared up and now recall all the contents of this topic. So for a little more knowledge, let's take a look at our next segment, Knowledge Dip.
Well, mostly conceptual questions are asked from the chapter P block elements. However, sometimes problems may also be framed from the structure of various oxyacids based on representative ability.
I hope the Knowledge Dip will help you organize your preparation for examinations in a more concise way. So without wasting much time, let's start with a model question.
Here you have to explain why 1. Sulfur vapors are paramagnetic. 2. Ammonia has greater affinity for protons than phosphine. 3. The negative value of electron gain enthalpy of fluorine is less than that of chlorine. 4. SF6 is much less reactive than SF4. And 5. Of the noble gases, only xenon is known to have well-established chemical compounds. This problem is worth 5 marks and tests your conceptual skills. It was asked in CBSE 2008 examination. Each part is worth a mark. Take a look at the answer now. At high temperature, sulfur exists as sulfur vapors, S2. It has 2 unpaired electrons in its pi anti-bonding orbital. So it is paramagnetic in nature. In the second part, you should write that the nitrogen present in ammonia has great electron density due to its small size and high electron density compared to the phosphorus atom present in pH3. So ammonia acts as a beta-Lewis base, that is, donates electron and attracts protons. Coming to the third part now, where we were required to tell that why the negative value of electron gain enthalpy of fluorine is less than that of chlorine. Well, this is because the 2p orbitals of fluorine are smaller in size than the 3p orbitals of Cl. So when an extra electron enters its 2p orbitals, it does not experience much attraction, rather it faces inter-electronic repulsions due to its compact size. But in chlorine, new electron experiences more attraction because of bigger size of chlorine. In the next part, we were supposed to give reason for why SF6 is much less reactive than SF4. So, you should mention that in SF6, the sulfur atom is octahedrally surrounded by 6 fluorine atoms. Thus, all the electron pairs of S are used up. Further, the F atoms provide high steric hindrance for incoming agents. In SF4, there is 1 lone pair on sulfur atom. Further, due to 4 F atoms, it does not experience much steric hindrance. Hence, SF6 is much less reactive than SF4. And now, we reach the last part. In this, we had to tell that why of the noble gases, only xenon is known to have well-established chemical compounds. So, here comes the explanation. The xenon atom has low ionization enthalpy as compared to the other noble gas atoms. Due to its large size, it has greater tendency to form compounds with highly electronegative atoms, like oxygen and fluorine, forming various compounds.
So after solving that question, it seems you're all set to take up the practice questions. Practice makes perfect might be a cliche, but it's true. So let's hit the bullseye and begin our practice session. Here comes the first problem.
Here you have to tell that why 1. pH3 has lower boiling point than NH3, 2. Nitrogen molecule is highly stable, and HI is a stronger acid than HCl. This is a concept-based 3 marks question and involves the application of 3 topics. So do not panic, read the question carefully and apply the concept of atomic size and hydrogen bonding to get the answer. So the answer for the first part is: the boiling point of NH3 is higher than pH3 because NH3 molecules undergo intermolecular hydrogen bonding due to the small size and high electronegativity of nitrogen atom, whereas pH3 molecules are not associated through hydrogen bonding because of the large size of phosphorus. Here you get 1 mark. For the next part, you shall write that the nitrogen molecule is highly stable because the bond dissociation energy of the triple bond of nitrogen molecule is very high due to the small size of nitrogen and the small internuclear distance of nitrogen molecule. So 1 mark more is added to your kitty. And now, the last part, where we asked that why HI is a stronger acid than HCl. So, due to larger size of iodine as compared to chlorine, HI has a lower bond dissociation enthalpy than HCl, thus making release of H+ easier in HI. Hence, HI is a stronger acid than HCl. Bingo! You get the last 1 mark also.
When I was a child, I used to wonder if there was an audio cassette or a video which I could play and learn my lessons with, just like learning songs. Well, my dream has now come true. At Topper, you not only hear but watch and study. Watching television was never so much fun and learning. Well, let's get back to the P block elements. To ease your preparation process further, let's attempt another question.
You are supposed to give reasons for why 1. Bleaching of flowers by Cl2 is permanent while by SO2 is temporary. 2. Bond angle in pH4+ is higher than in pH3. 3. Nitric oxide becomes brown when released in air. 4. PCl5 is ionic in nature in solid state. 5. And ammonia is a good complexing agent. This is a 5-mark problem that will test your concepts. Topper rates it as an average one. Each part is worth a mark, so attempt them carefully. The answer for part 1 is Cl2 bleaches by oxidation while SO2 does it by reduction. In case of SO2, reduced product gets oxidized easily again and the color is regained. Now for the second part, both pH4+ and pH3 contain sp3 hybridized orbitals. In pH3, there is a lone pair of electrons on p which causes repulsions to bond pairs, thus lowering the bond angle, while in pH4+, all orbitals are involved in bonding and there is no lone pair. The bond angle is higher. In the third part, we had to tell that why nitric oxide becomes brown when released in air. Well, nitric oxide is colorless gas which reacts with air and gets oxidized to NO2, which has yellow-brown vapors. For part 4, You should mention that PCl5 is ionic in nature in solid state because in solid state PCl5 exists as PCl4 plus and PCl6 minus. And due to this nature, it conducts current on fusion. And in the last part, we were asked that why ammonia is a good complexing agent. So you should write that the nitrogen atom present in ammonia has lone pair of electrons, which can coordinate with other atoms or cations, needing electron pair for stability. Being small in size and highly electronegative, electron density on nitrogen is high. Thus, ammonia serves as a good complexing agent.
You must have got a good idea of the question paper's format and the answering style. But for a better overview, you can always visit our website, and that's www.topperlearning.com, and practice more questions there. But there's loads more coming up, more practice questions, the HOTS problem, and special tips to give you that extra edge over others. Right now, we'll take a short break, and as always, here's your breaking question.
So you need to tell that which neutral molecule would be isoelectronic with ClO-. I had left you with a question before the break. Did you think about it? We asked that which neutral molecule would be isoelectronic with ClO-. So the answer is, the neutral molecule isoelectronic with ClO- is ClF.
Welcome back. I'm Arjun and you're watching Exam Special on the topic P block elements. Till now, we have solved a model question and some practice questions based on the properties of P block elements like the electronic configuration, electronegativity, size, and various physical and chemical properties. But we aren't done yet. There are more questions left. So without wasting time, let's get back to them.
Here you are asked that, why are interhalogen compounds more reactive than the corresponding halogens? This is an average problem that tests your conceptual skills. It is worth 2 marks. The bond between 2 dissimilar halogen atoms is weaker than the bond between 2 similar halogen atoms. So the bond dissociation energy of interhalogen compounds is less than the bond dissociation energy of halogens, due to less effective overlapping of atomic orbitals of 2 different halogen atoms than between similar ones. In other words, XY bond is weaker than XX and YY bonds.
I'm sure by now you are absolutely ready to solve the HOTS problem, but I think we should practice one more question before that. So let's see the 4th question and what it demands of us.
You are supposed to explain why ClF3 exists, whereas FCl3 does not. The question is a 2-marker. It tests your knowledgeability and Topper rates it as an average 1. In the answer we will write, the electronic configuration of Cl is 1s2, 2s2, 2p6, 3s2, 3p5. An electron from 3p orbital can jump to 3d orbitals, thus giving sp3d hybridization. So it can show an oxidation state of +3 and combine with the more electronegative fluorine. Whereas the electronic configuration of F is 1s2, 2s2, 2p5. No d orbital is available for excitation of electrons. Moreover, fluorine is the most electronegative element, so it shows an oxidation state of -1 only.
The practice questions must have filled you with complete confidence. So it's time to go to our HOTS segment now. HOTS questions have been introduced by the CBSE to test the high-order thinking skills of students. Here's one such problem just for you.
Here you are asked to A. Describe the favorable conditions for the manufacture of 1. Ammonia by Haber's process and 2. Sulfuric acid by contact process. B. You also have to draw the structures of 1. PCl5 gaseous, 2. S8 gaseous, 3. ClF3 gaseous molecule. This question involves a thorough knowledge of Haber's and contact process. It also demands a clear idea of shapes of molecules with knowledge of number of lone and bond pairs of electrons involved. Since it carries 5 marks, so it is quite obvious that each part is worth a mark. Let's begin now for part 1. For the manufacture of ammonia by Haber's process, the pressure should be about 200 atmosphere and temperature of 700 Kelvin and the use of a catalyst such as iron oxide with small amounts of K2O and Al2O3. 2. Now we have to tell about the favorable conditions for the manufacture of sulfuric acid by contact process. So the conditions are low temperature and high pressure. But very low temperature lowers the rate of reaction. Thus, practically a temperature of 720 Kelvin and a pressure of 2 bar is used. You will get 2 marks here, 1 mark for each answer. Moving on to the structure of PCl5 gas, you shall mention that in gaseous and liquid phase, PCl5 has a trigonal bipyramidal structure. In PCl5, the 3 equatorials PCl bonds are equivalent while the 2 axial bonds are longer than equatorial bonds. Now the structure of S8 gas. The rhombic sulfur exists as S8 molecule. The 8 sulfur atoms in S8 molecule form a puckered ring. Here you add 1 mark to your scoreboard. Lastly, coming to the structure of ClF3 gas. So, the chlorine atoms present in ClF3 has 5 electrons in the 3p orbitals. 3 of these are used in ClF bond and 2 are non-bonding or lone pairs. The 2 lone pairs occupy equatorial positions at an angle of 120 degrees to each other. The repulsions involving lone pairs are stronger than those involving bond pairs, so the molecule is a slightly bent T-shape. For drawing all the structures correctly, you get 3 marks, 1 mark for each structure.
So the HOTS question is finally done, but you can find many such questions on our website. That's www.topperlearning.com. So practice those as well for better results. Well, everyone looks forward for some special tips to learn the best ways of answering questions. So here are some exclusive tips just for you. Take a look.
This chapter carries a weightage of 8 marks out of the total 70 marks chemistry paper, and conceptual questions are asked. So don't simply learn the various physical trends, rather go for a table-based comparative studies of the different periodic trends. Practice the structures of various oxyacids on paper and keep in mind the number and positions of atoms and bonds so that it is easy to visualize them at the time of examination. Also make a comparative table of the factors enhancing the yield of various products like ammonia, sulfuric acid, etc., as questions are frequently asked on them. And learn all the reasoning and the important points given in the NCERT book, as they are very helpful while answering many important conceptual questions.
That's all from me today. Keep the smart work going and don't forget to take a great deal of confidence and positive attitude to the examination hall. See you next time with another episode of Exam Special. Till then, take care and study well.